Hi. Okay, for math today, first of all, I hope that you watched the review. And I still need to go back through those show what you knows and look for how you did on question number 3, because I said that I would count that maybe as an additional mark if you put 13. Okay, so stay tuned. It's going to take me a little bit of time to do that, okay? But I will have it done by the end of today. Okay, today, so now that you've done the review, we're going to start with our new lesson today. But first, we're going to do our activity challenge. So arms up, and then pull them back, down the slide, and then into your back pockets. Squeeze. 3, 2, 1. Good. 2 more. Arms up, and pull back, down the slide, and then squeeze your shoulder blades into your opposite pockets. Hold. Squeeze. 2, 3. Good. 1 more. Arms up. And then pull back your arms down the slide, and then squeeze your shoulder blades into the opposite jean pockets and hold. 3, 2, 1. Good. Okay, there. We've done 2 times today. We have 3 more minimum left. Okay, so first of all, homework from the other day was the pictograph and the pie graph and the, 7-leaf plot. So I'm going to be looking through those, and that does count for a small homework mark. So this is all, it all adds up, so you might as well do it. I'm just gonna give points to people who are done this. So let's see. Okay, first of all, I'm gonna give people points. Okay, there's 2 things. This is seesaw, okay? Okay, so this was the bar graph, okay? So I'm gonna give points to people who were done this, and then I'm gonna give points to people who were done the other one, okay? So might as well just rack up these points. Here we go. So this is from the bar graph. We had, let's see, okay, Malik and Metha and Ali, Ada, Hisham, Soyun, Ada, Hisham, Soyun, Daisy, Mohammed, Rami, Daniel, and Fassi, and Alex, and Ryan, and Zaha, and Rita. Good work, you guys. Okay, so you guys are getting a point for math task done. Okay, that was from the bar graphs. Okay, that was from this one. Now I'm going to do this other types of graphs. Okay, so there's a number of people who need to do this, and I suggest that you stop the video even after this moment right now, and then finish this up, and then come back and watch what we're doing today. Okay, so these are people who were done. Malik and Ali, Metha, Ada, and Soyun, Daisy, Daniel, Fassi, and Alex. Okay, good work, you guys. So you guys also get math task done. Very good. Okay. Right on. So now we're getting into our new lesson for today. So if you have not got those things done, I suggest that you stop this video right now and you go finish that and then come back and watch, okay? Because it's going to be too much. If you have, then it's going to be 3 things. Better to get the 2 things done and then have the new one from today. So, okay, here we go. You need to write in a new page. Today we're going on to line graphs, which is more now of the grade 6 stuff. The prior stuff was more of review. So, which means that you should have gotten super high marks on those easy 2 things from the other couple of days. It was meant to be only a help to your math mark. Okay, so I can create, label, interpret line graphs to draw conclusions. Okay, so before we were doing different types of graphs, but now we're moving into specifically line graphs. Okay, so there are two different types of graphs that we're learning about today, which are kind of like you have to be able to understand. So the first one is called points on a graph, okay, or series of points or scatter plot, okay? So this is like kind of like this is like method number one. You're gonna see there's gonna be two different types we're gonna be doing today, okay? So series of points or scatter plot. So scatter, what does scatter mean? You just like throw down points on a grid. This is what it would look like down here. Okay, so this is super important stuff. This shows discrete data that involves categories. Okay, this is one of the most important terms that we're learning for math today, and actually even for like the unit, is what we're doing today, which is discrete. There's two different types, discrete, and I wonder if anyone knows, there's another one that we learned that was from your title page. If you know it, you can say it to yourself right now. It'll be on the next page. Good little brain challenge. So discrete data shows categories. So it could be, for example, days of the week. So a category, Monday, separate than Tuesday. It could be months of the year. This one shows number of families. There was not one family, or like, I don't know, maybe up to like 5 different families. Okay. Now, okay. This is so the tip is the order of the categories will now matter. So, and usually they are ascending. So this is very, very, very similar to bar graphs, okay? In fact, they could be a little bit difficult to be able to determine the differences between them, but and you could use them interchangeably as well. The key thing is for bar graphs, if you remember the other day, they usually involved like categories that could be jumbled up in an order. So like ice cream flavors or subjects or sports teams, right? Like doesn't matter what one you put first. But for a series of points, sometimes though bar graphs do matter for the order. Like coronavirus cases, right? Like they're using bar graphs for that a lot of the time that we're seeing. And the order does matter. They would put them in like the days in ascending order according to like time order. For a series of points, it's the same. It would be ascending order or a logical order that you would expect to be next. So like months of the year, you wouldn't do it in jumbled up order, right? Days of the week wouldn't be a jumbled up order. It would be in ascending order. Okay, so that's kind of one distinction. The next thing is for making like this series of points or scatter plot is you just put a single point is just placed on the graph. So like this, rather than doing a bar. Okay, that's really the only main difference so far, which is very similar to a bar graph. Okay, so an example, what could be a question that we could write for this graph? And this is could be a question that's going to be like popping up is you have to be able to kind of partially interpreting, right? This goes with like the not only create and label, but like interpret. And I guess label because we could put a title on it. Okay, so number in the family, number of families. Okay, so family 1, 2, 3, 4, 5. If there's 5 families, okay, so number of families. What could be this? Number in the families. What could be the question? If we were in class right now, we'd be having a little talk about this. So think about it. Like, what could be the question? What could be the title? Could be maybe number in the family. Maybe number of children in the family. Maybe it's number of pets in the family. Maybe it's number of bicycles the family owns, right? I don't know. Maybe it's number of vacation the family goes on. Maybe it's number of, I don't know, plants or trees the family has. Okay, so really, it's kind of general. Okay, so you can write up your own. What could be a title or what could be a question that could be shown for this graph? Alrighty, now, so that was number 1, which was, okay, series of points or scatter plot. Now the second one is called a line graph. So make sure that you have this kind of standing out, similar, such that you had this standing out on your page, okay? So second heading is line graph. Now, this is the major distinction. This shows continuous data that involves numbers that can be fractions or decimals. So basically the word continuous means that the data goes continuously between values, okay? Super, super, super important to understand this, okay? Discrete data is like number, so like the one I had before, like number of cars, number of pets. You can't have 1.5 cars. You can't have 1.5 pets. You can't have 1.5 bicycles, okay? It has to be a full value. No fractions, no decimals, not allowed, okay? And don't do I know you're thinking, well, what if they had a broken bicycle? Just like think logically. If you think in the what ifs, you're gonna get the question wrong, okay? So just like, that's it. No fractions, okay? But for continuous data, you can continuously show values between the data points, okay? So, for example, this one that I have for you, okay? This one, which is Josh's bike trip, okay? So, Josh was going on this bike trip, okay? He went for an hour and 20-minute bike ride. I am jealous of Josh. I wish that I could go for a bike trip right now for 120 minutes. Not possible here in Qatar. So, okay, then miles from home. So it wasn't just like 0 minutes, then bam, 20 minutes, right? He had 1 minute, 1 minute and 10 seconds, 1 minute and 11 seconds. So it's like continuously changing. Same thing with the miles from home. He didn't just like suddenly teleport from like 0 miles to 2 miles. He continuously moved from 1 kilometer, 1.1 kilometer, right? 1.2 kilometers all the way till here. So it's both of the values, okay, on the X and the Y axes. Very important. The values on the X and the Y axis are both able to be fractions / decimals. You can get values between both of them. Whereas our earlier example of the scatter plot or the bar graph, can we have 1.5 people? No. Can we have, technically for like the days, you could show like, you know, differences upon days, but for like example of coronavirus, they're gonna count per day, right? Like how many cases were there today? P.S. Do you want to know how many cases there were in Qatar alone, new cases yesterday of coronavirus? It's gonna blow your minds. 2,360 something or other. It's awful. There was 2,000 the day before, and there was 1,700 the day before. It's been like over 1,500 for the past 2 weeks. That sucks. But luckily there's not many people who were dying, which is also very good. Anyway, so yeah, coronavirus would not work for a line graph, but it would work for scatter plot because you can't have half a person, you can't have half a day, okay? Alrighty, so there we go. Okay, now, okay, so this shows, okay, so here are some examples. What could be used? Time and temperature, right? We can have like fractions of time, we can have decimals and fractions of temperature. What else? Money, right? And basically measurements of any type, anything that you can measure, not specifically count, okay? All right, so then what you do is you plot the plot points placed on the line graph. That's a alliteration. The plotted points placed on the line graph can be connected by a line because then you can interpret, well, how far has Josh gone when it was 18 minutes, right? You find where 18 minutes would be about here, and then you just draw it across 1.8 maybe, for example. Okay, that's it. So this is your homework. Page 61, 62, questions 1 to 5. Not due Thursday, silly. It is due on Monday, tomorrow. Okay, so this is it. Okay, you're gonna see it's all of this differences between discrete and continuous data, and then just like analyzing it. You're not drawing anything today. The only thing you're doing is just analyzing. Okay, alrighty, that is it. So please, I really have to have those 2 other things done because they're gonna count for like little tiny homework marks. Okay, see you soon.